In 2003, the FBI apprehended 44-year-old Andrew Carlson. Media outlets shared stories about his unprecedented good fortune. He achieved unparalleled success in the stock market. Starting with an $800 investment in a fortnight, it escalated to a staggering $350 million. The FBI assumed it was a deceptive scheme. They believed he had inside information. When questioned, Andrew's defense was astonishing. He stated he was from 250 years ahead in time, and his knowledge of stock trends was the reason for his success. This left the FBI bewildered. They were adamant about his deceit. They sought to uncover his falsehood. Further inquiries revealed that, prior to December 2002, Carlson was virtually non-existent. More shocking was when, on April 3, Carlson was due for his bail hearing. He vanished, never to reappear. Could he have been a genuine time traveler? Is time travel a reality? Or merely a creative narrative? Today, we'll delve into the scientific perspective of time travel. Wait, are we discussing a temporal machine? Aware of time leap protocols, aren't you? Time travel, a theme touched upon since the early 20th century. My knowledge is limited, but when discussing time travel, it's either all a ruse or entirely genuine. In 1895, author H.G. Wells penned the iconic The Time Machine. This work brought the term time machine to the forefront, a contraption to journey to both future and past. Through it, one can navigate through eras. Though purely fictional, it stirred curiosity among thinkers and scholars. This theme not only led to academic pursuits but also cinematic adaptations. Considering the varied time travel methods, they can be categorized distinctively. For clarity, let's use cinematic references. Different modes of time travel exist. Firstly, irreversible journey into the future. Once in the future, there's no turning back. Interstellar is a depiction of this. The protagonist moves forward in time, but loved ones age or pass away. The next mode is immediate temporal leaping. One can shuffle between time points instantly, using a specialized device. Examples include Back to the Future and The Girl Who Leapt Through Time. Another method sees time revolving around the stationary traveler. Harry Potter, Prisoners of Azkaban, portrayed this, with Hermione's time turner. Then there's gradual time travel. The 2004 movie, Primer, showcased this. A traveler stays inside a container. Each minute inside equates to a minute back in time. Thus, a 24-hour stay takes them a day back. Lastly, the concept of attaining light speed to traverse time. Superman, in the 1979 film, exemplifies this. Flying beyond light speed, he rewinds time. The real question is, which, if any, of these modes are feasible today? Or even in the prospective future? And which are sheer fantasy? It might astonish you, as some of these methods are not just figments of imagination. At a high level, time travel splits into two categories: venturing into the future and retracing steps into the past. Let's discuss forward time travel initially. This idea finds its roots in Albert Einstein's special relativity theory. Introduced by Einstein, time dilation is a pivotal concept. Pre-Einstein perception of time. Before Einstein's theory, time was seen as unchanging whether on Earth, Mars, or near a black hole. Newton's take on time. Isaac Newton, a prominent physicist, saw time as constant, unaffected by speed or location in space. Einstein's revolutionary view. Einstein disagreed with Newton, suggesting that time varies. He likened it to a river, which can flow at different speeds under different conditions. The concept of time dilation. This variable flow of time, affected by speed and gravity, is termed time dilation. Just like pupils can dilate, time can too, especially with increasing speed or gravity. Practical demonstration. This was practically shown in the Haffel-Keating experiment in 1971. Two clocks, one stationary and one aboard a plane, displayed different times after the plane's journey due to their different relative speeds. A matter of perspective. It's not that time actually decelerates, but its perception is relative. In theory, if we could journey at light speed for 10 years, upon return, Earth would have aged by 9,000 years. Gennady Padalka's time leap. Astronaut Gennady Padalka holds the record for the furthest travel into the future, owing to his long stay in space, making him younger by 0.02 seconds in comparison to us Earth dwellers. Gravity's role in time dilation. Another form of time dilation occurs due to gravity. The stronger the gravitational pull an object experiences, the slower its time seems to progress. Black holes and their influence. Black holes, with their intense gravitational fields, profoundly impact time. This effect was highlighted in the movie Interstellar. A nearby black hole can considerably slow time's passage. The significance of 2019's black hole image. In 2019, the Event Horizon Telescope captured the first visual evidence of a black hole, a milestone that verified several long-held theories. GPS and the time dilemma. The clocks on high-speed, high-altitude GPS satellites experience time dilation effects. They must be adjusted regularly to synchronize with Earth's time. The sci-fi solution, cryosleep. Cryosleep offers another speculative method to move into the future, as showcased in films like Passenger. In cryosleep, individuals are put into a prolonged, ageless slumber. Science fiction and NASA. Science fiction often inspires real-life innovation. NASA is currently exploring the concept of a stasis chamber. The stasis chamber. In this chamber, astronauts could be subjected to mild hypothermia, enabling them to sleep for up to 2 weeks continuously, similar to hibernation. Reason behind the chamber. The idea is that a cooler body slows down chemical reactions. This not only conserves energy but also potentially slows the aging process. The Japanese survival case. A real-life example from Japan hints at this. A man endured 24 hours without sustenance after an injury caused his body to hibernate. Remarkably, despite his body temperature dropping to 22 degrees Celsius, he fully recovered without lasting damage. Cryosleep. NASA might be looking at cryosleep as a potential future development, but it's still in the theoretical phase. Seeing the past. Traveling to the past remains elusive. Yet, the time it takes for light to travel allows us to glimpse the past. Light from distant stars, for instance, gives us a window into events that happened years ago. Stephen Hawking's time travel party. In 2009, Stephen Hawking held a unique party at Cambridge, inviting time travelers from the future. No one showed up, humorously suggesting that backward time travel might not be possible. Einstein and wormholes. Einstein theorized that intense gravitational force could create wormholes in space-time, potentially allowing for time travel. Achieving this would require a gravitational field similar to that of a spinning black hole. Kip Thorne's theory. Kip Thorne, a Nobel laureate, believes that space is filled with small, temporary wormholes. To travel through them, we'd need to expand them using both conventional and negative energy. Paradoxes and time travel. Traveling to the past introduces paradoxical situations, like the well-known grandfather paradox. The theory of multiverse attempts to provide an answer, suggesting that any action in the past creates an alternate universe. Examples in film. Movies like 12 Monkeys, Time Crimes, and Predestination explore the complex implications of changing the past. Current state of time travel. While time travel to the past poses logical challenges, moving into the future and glimpsing the past are somewhat feasible today. Misinformation and Andrew Carlson. The tale of Andrew Carlson, mentioned earlier, was a fabricated story from a satirical source, but it was mistakenly reported as truth by some media outlets. Suggestions for future topics, especially mysterious ones lacking scientific clarity, are welcomed in the comments. Thanks for watching.